session, we'll be looking at how to solve some basic problems related to wind turbines and wind energy. We'll look at the tools and formulations that we will require. We'll look at some of the basic techniques of what must be done for virtually any of these problems. We will be referring to some of the questions in our problem sheet. In particular, we'll be looking at questions from 27 onwards. The work we do here will not be exactly the same as the questions that's in the problem sheet. It is advised that you work through this problem sheet on your own. If you have any difficulties, ensure to reach out. So let's begin. So let us consider a wind turbine. It could be a two-bladed wind turbine, it could be a three-bladed. But we're going to take some initial data. We're going to have a coefficient of performance that's associated with this wind turbine, and we're going to say that's approximately equal to 0.32. We're going to say that the wind turbine, so we'll say the turbine, is rated at 2 megawatts in a wind speed of 13 meters per second. We will say that we've got an efficiency associated with the gearbox of approximately 94%, and we'll also say we've got an efficiency associated with the generator of approximately 96%. We want to determine what is the wind turbine diameter. We're going to also assume that the density of air is equal to 1.225 kilograms per meter cubed. So this is the information we have: a coefficient of performance, a rated power output for a given wind speed, a gearbox efficiency, and a generator efficiency. We also know that the density of air is 1.225. So what's the first thing we're going to do with this problem? So the first thing we need to do with this problem is we need to look at what is the formulation that we can use, or what is the basic formula. So there's a governing equation that we're going to be concerned with. And the governing equation in this case is the equation that's going to allow us to determine what is the power that's available in the wind. So we'll say the power that's available in the wind is going to equal to 1/2 times the density of air times the area of the wind turbine times the velocity cubed. Now, that's very fine for us, but we also have to take into account that the wind turbine has some efficiencies and some losses that's associated with those. So we need to determine what would be the power, or what would be the diameter to extract the energy from the wind turbine. So we're told that the rated power is equal to 2 megawatts. So we need to think about what is the power for this rated wind turbine. So power R is going to be equal to the coefficient of performance multiplied by 1/2 times the density of air times the area times the wind speed cubed multiplied by the efficiency. And that's the total efficiency we're going to say here. So this is the formula that we're going to want to use in this problem. So we're going to manipulate this formula to start out with. And what we want to do is we want to identify the diameter. So we're looking for area. So we want to isolate for area. So the way we're going to go about doing that, we're going to manipulate this formula to get it in terms of area. So we're going to say that the area is going to be equal to the power at the rated wind speed divided by the coefficient of performance times 1/2 times the density of air times the velocity cubed times the overall efficiency in our wind turbine. We were also told that the efficiency was going to be equal to the efficiency of the gearbox multiplied by the efficiency of the generator. So we must take that into account as well. So therefore, we can say that the total efficiency is going to be 0.94 multiplied by 0.96. I think that's the two values we were given in the question. So we want to work that out first of all. So to start with, therefore we need to get our calculator. So we're going to say 0.94 multiplied by 0.96 is going to give us a total efficiency of 0.902, so roughly 90%. So now we're going to fill in the values into our formula. So our area is going to be equal to the rated wind speed, which was 2 megawatts, and that's going to be divided by the coefficient of performance, 0.32, multiplied by a half, times the density of air, 1.225 kilograms per meter cubed, multiplied by the wind speed, which was 13 meters per second, and that's cubed, multiplied by the efficiency, which is 0.902. And when we actually do the calculation on our calculator for that, we find that our area is 5,149 meters squared. We know that area is equal to pi d squared over 4. So therefore we can set the pi d squared over 4 equal to our 5,149 meters squared, and we can calculate out the. So we know d squared is equal to 6,556. That's meters squared. And we are going to get the square root of that. So therefore we find that the diameter is 80.9 meters. Now that's a very simple example of how to calculate out one of these problems. Now that is a very basic example of one of these problems that we will be required to solve. So it's key for us to remember that the power that's available in the wind is equal to a half times the density of the air times the area times the wind speed cubed. If we wanted to find any one of these components, we want to be able to manipulate that formula. The power at the rated wind speed is the coefficient of performance times half times the density of air times the area times the velocity cubed times the efficiency and the overall efficiency of our system. If we wanted to manipulate this equation, say we wanted to find Cp, for example, well then that's simply going to be Cp is equal to the power that is rated at divided by a half times the density of air times the area times the velocity of the wind cubed times the efficiency. Or maybe we want to find the wind speed. So if we wanted to find the wind speed, we would be saying that U is going to be equal to the cube root of the rated wind speed divided by a half times the density of air times the area times the efficiency. So you can manipulate these formulas in a number of different ways. So it's up to you to be prepared to adapt the formula that's needed for each of our problems.